You could do this using UVAST, okay? And what we discovered in the last day was there's a quicker way of doing it. That's called a Flusty time diagram. So you set up an XY axis like so. You put Flusty here, and you put time here. Is that all right so far? Next thing, if you start from rest, what does that mean? When time is 0, velocity is 0. You essentially start at 0, 0. Now, you accelerate to a speed of 50. So what does that mean? What happens to your velocity as time goes by? You accelerate until you hit 50. You travel at a steady pace. What does that mean? No acceleration, so you're staying the same speed. Flat line. Question for you. Which is bigger, the acceleration or deceleration? The deceleration is 10, but the acceleration is 5. So what do you think? Yeah, so here's a little trick for you. See this yellow line? That's the time spent accelerating. It should be twice as long as the time spent decelerating. Why? Because the deceleration is twice the acceleration. So that's a little trick you can use. Don't necessarily need it just yet, but it's a great trick that you will learn. So essentially, the blue line is half the yellow line. Everybody cool with that? If you were in a question that you didn't know the variables, you could say that's 2t and that's t, if you get what I'm saying. Yeah, because you spend twice as long. So I did this in the last video, but we'll go again. It's the ratio of acceleration to deceleration, provided you're starting and ending at the same speed. See the way you start at 0, go to 50, and then you start at 50, go to 0? It's symmetrical, which means they obey this rule, okay? So the rule is if it's 5 is to 10, that's 1 is to 2. That means the time spent accelerating is 2 times the time spent decelerating. You won't need that in a minute, okay? Now, next thing you're going to find quite easy is we spent 25 seconds in the middle. Are you happy enough with that? What's 25 times 50? Remember, distance equals speed multiplied by time. So 25 times 50, anybody? 1,250? Is that correct? The distance you travel, oddly enough, is the area of the triangle plus the area of the rectangle plus the area of the other triangle. That will actually give you the total distance traveled, believe it or not. Okay, so we can say here is that's 1,250 for the rectangular part. Okay, now we have enough information to get the acceleration, but I'm going to show you a really quick way of doing that as well. Acceleration is actually tan of your acceleration triangle. So what's tan x again, guys? Tan x is opposite divided by adjacent. And what does that equal? The acceleration, which is, anybody? Acceleration is 5. Everybody cool with that? Now, I'm essentially telling you that acceleration is 5. Oh, wait. Not 1,250, it's 50, isn't it? I was just thinking that's the most massive acceleration I've ever done in a question. So 50 is the height of the opposite, 2t is the adjacent, correct? So what do we get here? 50 cross multiply, you get 10t equals 50, and then t will equal, anybody? 5. So that makes this 5 and this one 10. Okay. Now, a half 10 times 50 plus 1,250 plus a half 5 times 50 to get your total distance traveled. So what you get here? A half 10 times 50 plus 1,250 plus a half, 5 times 50. Okay, and this will equal 250 plus 1,250 plus 125, is it? Half 5 times 50, 125. Add them all together. 250 plus 1250 plus 125. And you get 1,625 meters. Okay with you guys? Now, next thing we're going to do is the average, before we do that, what I've done there is I've shown you the graph method for doing this question. Everybody cool with that? You always could have done UVAST if you wanted. You could have said UVAST, U is 0, phi is 50, A is 5, and you could have used U, phi equals U plus AT, couldn't you? Where 50 equals 5T. Excuse me. And then T will equal 10. 10 seconds for the first part. Everybody cool with that? So you could have used your formulas, but distance time diagrams work out faster. They're much faster, so they're better in the exam. When you can use them, use them. Okay? So, next thing we're going to be doing is the average speed. Now, how do you get the average speed, lads? Total distance divided by total time. So what do we get here? 1,625 divided by what? 40. And 1,625 divided by 40 as well. $40.625. Meters per second. Now, I want to surmise, what did we learn here? Two things we learned. First thing, a couple of things we learned. First thing is you can do a distance time graph. Everybody cool with that? Second thing is the ratio of acceleration compared to deceleration reflects the times taken accelerating and decelerating. Accelerating and decelerating. What's the third thing we learned? Area under the graph is what? The area under the graph, which is the triangle plus the rectangle plus the other triangle, is what? Is the distance traveled. Okay? So we learned a lot. You generally use distance time question when there's just one car, not two cars. Okay, you're usually able to use them if there's only one car, okay? So now I want you guys to set up an XY axis. Your velocity tops out at 40. Your acceleration is gradual. Then you travel at a steady speed. And then your deceleration is more aggressive because you decelerate at 5 compared to accelerate at 2. That means this is going to be it's going to be steeper than the other one. All right. Now, if I was doing a cheeky trick in a harder question, I'd once again say that the time spent accelerating compared to the time spent decelerating will be something like this. The ratio between the two of them is, 2:5. So that means that one will be 5t for that once, 2t. Does that make sense? That's just it. Now, you might not necessarily need that trick right now, but it is there. Okay? Now, the trick we're going to use is, I'm going to find the time taken. Okay? Now, the trick we're going to use is that this opposite is 40, isn't it? What does tan x represent? Represents the acceleration. Perfect. And tan x in this question will be 40 divided by, and that equals what? Equals 2, doesn't it? So 10t equals 40, and after that, t equals 4. So there's some easy money for you, okay? So this time here is going to be 20, and this time at the end is going to be 8. How do you find the distance during acceleration? What triangle are we talking about, the left or the right? Find the area of the triangle on the left. So what do you think? A half base times height? $400 meters. All right. Next part is the distance covered during deceleration. And once again, it's the area of the triangle involved. So it's going to be a half 40 times. Sorry, half 40 times 8, which is 160 meters. All right. Does anybody knows the cheap correlation between the two of them? The ratio of the deceleration compared to the acceleration. 5 is to 2. It's the same as 400 is to 160. You don't have to remember that or anything like that, but it just sort of checks your answer almost, doesn't it? Just something to know. Now, if the entire journey was a kilometre long, what does that mean about the rest of it here? This will be 1,000 meters. So how much meters are left over? 440. So 440 belongs to the middle section, where you are traveling at constant velocity. So time equals distance divided by speed. And what would that be in this case? 440 divided by, what was your speed at that point? 40, which is how many seconds? So 11 seconds. Okay. What's the total time taken then? 39 seconds. 20 plus 8 plus 11 gets you your 39 seconds. Okay, we're good. So we've done 3 and 5. Right, 1 sec. You start at point P, but I'm about to make a mistake here, guys. Can anybody tell me what my mistake is? I start at 15 and go to 25. I'm starting at the origin, which is not where I should be starting from. Where should I be starting from? 0, 15 is my starting off point. So this is 15, this is 25. Okay, do I hit a steady speed? Okay, I accelerate from P to Q, and then I stay from Q to R, and then that is my speed distance diagram. Okay. Now, how many different objects do you see here? Get the area of triangle rectangle A, get the area of triangle B, and then area of C. So what can you say about all 3 areas added together? A plus B plus C has to equal what? 980. Okay? And then also you guys need to do is find out the time. You can find the time quite quickly. Using phi equals u plus at if you want, you can find that quite quickly. You know what the yellow part is, don't you? What's the yellow part? Yellow part, anybody? 10. What's this part here? 15. So find the time taken to accelerate, and then you can then find the area of A and the area of B. And then just call the base of C, just call this T, because you don't know how long you spent at that speed, do you? But you do know the height is 25, so off you go. I'll give you a head start on me. Now, what we're looking at here is you can use phi equals u plus at if you want, and you can say that phi equals final velocity is 25, initial velocity is 10. Your acceleration we don't know, do we? Just tell us the time taken. Yours 980. Oh, we know the total time, don't we? Sorry, that's my fault there then. This is going to be t take away 40. Is that okay? If one time is t, the other time is t take away 40. Is that all right with you guys? Because t1 took the time taken from, oh sorry, 40 minus t, my fault. Yes, both of them added together have to give you 40. Somebody else could have called that one t and that one 40 minus t. You'll get the same answer, okay? Now here's the trick. We're going to use an area. We're going to use areas to find this out. So what's the area of A, guys? It's 40 take away t by 15. What's the area of B? Once again, it's 40 take away t times 10. And finally, the area of C, it's going to be 25 times t. All we need to do is mill through this now. So it's going to be a half 15 times 40 minus t. Oh, sorry, it's a rectangle. Thank you. And rectangles, you don't need the half times the triangle, so it's going to be a half 10 times 40 minus t. And the last one is 25 multiplied by t, and this all equals 980. So we're going to get 600 minus 15t. This is going to be 5 times 40 is 200 minus 5t. That's going to be 25t, and that equals 980. Now, your t's are, we're going to end up with 5t on this side, plus 800 equals 980. 5t equals 180. This makes t 36. Good man. Have I answered the question yet? No. So, what's 40 take away t? That's 4 seconds, and that's 36 seconds. So if you use phi equals u plus at, your final velocity is 25, your initial velocity is 15. Your acceleration is what we're looking for, but we know you do it in 4 seconds. So that'll be a times 4. 10 equals 4a, therefore a equals 2.5. You all good? I had one the other day, and what we found out was that the time spent accelerating was 60 seconds, the time spent decelerating was 20 seconds. Okay. We also found out that we spent 180 seconds. We spent 180 seconds in the middle section. Okay. And this means the total time is 260 seconds, okay? Now, something that we want to make you aware of is that if you look at this question here, the maximum speed over the final kilometer of the journey had been restricted to 20. The final kilometer of the journey would be starting here. Does everybody get that? Because it'll be 600 plus your 400 to give you 1,000. So I have to construct a new Flusty time diagram to make this work properly. Now, okay, everything else is still the same. So what's the same? You accelerate for 60 seconds to a maximum speed of, what's it, 40, isn't it? And you do that over 60 seconds. Okay, a half base times height will yield 1,200. Is that okay? Now, here's where things get tricky. You then travel. Do you think you travel all the way up to 8 kilometers? Do you think this should be 5,000, so was it 9 kilometers in total, is it? Sorry, 8,800 in total. Okay, so it's 8,800 in total. That means that the last kilometer from 7,800 to 8,800 has to be capped at a speed of 20. Do you think you just randomly, what mark would it be? The 7,800 marker, right? So if I add that onto 7,800, now I'm making a mistake, but I want you to tell me why this is a mistake. Do you think I can go all 6,600 meters? No, why not? I have to start slowing down before I hit the 7,800 mark. Do you get that? Okay, so what I'm going to have to do is, I can't just decelerate there. I have to stop and just back off slightly. And then I'm going to decelerate now. And I'm going to decelerate until I hit the 20 mark. Does that make sense? Now I'm going 20 kilometers an hour. Does it say I have to stop at rest? Does it say I have to come to rest? Rest to rest. Everybody see the language? So what does that mean then? Another deceleration period here. Why are both lines parallel? Or why should both lines be parallel? The same deceleration as question 1. Now, you'll actually see, how's it going? You'll actually see when I did you'll actually see when I did the previous question, I never actually got the acceleration. Okay, so here's how you get the acceleration. Acceleration equals we can call it tan x, can't we? And tan x is 40 divided by 60, and tan x is 2 over 3 ms2. Everybody cool with that? Now what if the deceleration be then? The deceleration is 3 times larger, so what do we know about the deceleration then? It's 3 times 2 over 3, which is minus 2 meters per second squared. So now we have our acceleration and deceleration sorted. Okay, now let's chop this up into little areas here. Okay, so would everyone agree there's an area A, an area B, an area C, an area D, and an area E? And what do all of them add up to? 8,800. If you use my handout, you'll see it's question 11 and it's 8,800. Okay? Now, we already know area of A. Which area can we get first, do you reckon? I reckon E will be an easy one. I'll tell you why. In area E, what you have is you start off at 20, you end up at 0. We know the deceleration, don't we? The deceleration is minus 2 or 2. So we know that tan x, which is 20 divided by t, and what we're trying to prove, guys, we're trying to prove that the journey is 22.4 seconds, sorry, 22.5 seconds longer. The first journey was 260. This makes this journey 282.5. That's what we're trying to prove. We're trying to get all the times added together. So at the end of this question, I want this time, this time, this time, this time, and this time. I want to add them all together, and I want to get 282.5. Everybody cool with that? Okay. Yes. No, because you decelerate quicker. I'll go through that in a second. Okay. I'm just going to start off with E because I can get E pretty quickly. Okay. So 20 divided by T, deceleration of 2. So it's 20 divided by T, and the deceleration is 2. You don't have to use minus 2, just the magnitude. And we get 2T equals 20, and then T equals 10. Is that okay with you guys? So T equals 10. Out of interest, what would be the area of E? What's a half 20 times 10? Huh? 100, isn't it? So you travel 100 during the deceleration period. No bother. Okay? Now, what's the next time we can find? I think we can find out C pretty quickly as well. How would you find out C? You could use U fast if you want. U equals 40, phi equals 20, acceleration is minus 2. Find the T value. Okay? So what do you reckon? So what do you reckon, guys? P equals U plus AT. 20 equals 40 minus 2T. 2T equals 20. Another T equals 10. Makes sense, doesn't it? Decelerating from 40 to 20 takes the same time from going 20 to 0 using the same deceleration. Yes? Just check it out yourself and you get the same answer, then you know your assumption's right. Okay? Now, everybody knows that the base of this triangle is 10, don't you? Now, here's the problem here. What's the area of the two sections combined? So the first one is easy. 20 times 10 is what? 200, isn't it? And what about this? What about the top one? A half 20 times 10? 100. Okay, so we're in business. I think what you said earlier is they're going to be congruent triangles, is it? And they're both exactly the same size. Yeah, so you didn't. The section where we got this to be 100, then what we said it was that this is 20, and this here is, anybody? Was it 20? Now we have something learned here is that the two sections here, the two blue sections here, they have to add up to one kilometer, because that's when you're restricted to your. You have to be at 20 for the last kilometer. That will make area D what? Area D will be 900. Okay, that's my fault there. So area D will be 900. Now, next thing is, what's 900 divided by 20? 900 divided by 20? 45 seconds. No bother. Now, we know this one's also 10 seconds, reason being, when you start at 40, go down to 20, yeah, an acceleration of minus 2, you can find out that the T value is 10. So that will make this section 200, because Flusty times time is 200, and then a half base times height will leave that at 100. Now, For the central rectangle, rectangle B, how much distance is left? So we get our 8,800. We take away 1,200. Take away 300. Take away 1,000. Keep an eye on me because 6,300. 6,300 divided by what? 40, because it's distance divided by speed. So 6,300 divided by 40. Please have a decimal. Thank God. 157.5. And what should happen when I add all the times up together? Plus 10, plus 45, plus 10. Please be 282.5. And you're done. All right.